Good morning, everyone. Today we're looking at Unit 6, Lesson 4, Subtracting Vectors. So remember, when we add vectors together, the vector that we get from that is the resultant. The same is true when we subtract them. So a vector can be subtracted from another vector to find that resultant vector still. So if we subtract vector u minus vector v, we're basically adding the opposite of v to u. So think about when you're subtracting something. For instance, if we're subtracting an integer, it's the same thing as adding the negative version of that integer. So thus, if we had u minus v, it would be the same as saying u plus a negative v. So let's take a look at an example. So consider the two vectors, vector u and vector v, and we are going to find u minus v. So first, we have to draw the opposite of v. So this is step one over here. So if I draw v in the opposite direction, draw v in the opposite direction. So the way we're going to do that, I'm going to take it, we're going to flip this a couple times. So you can see now we have v and it's pointed in the opposite direction. So now v is pointing in the opposite direction. So we could say this is a negative v now, since it's pointing in the opposite direction. If we were to then take that v and translate it, so it's on the head of our u, so let's translate it right there. And we'll just make sure we can still see our u. Our picture's kind of over a little bit. But that's what we're translating it to, okay? So again, you want to measure that v when we're actually doing the math out, when we're not using trigonometry to find these magnitudes. And then the resultant, so if I was to draw the resultant from the tip of one vector to the end of the other vector, that would be our resultant. And that would be represented as u minus v. Okay? So we translated that minus v. That was our step 2. So the tail of negative v touches the head of u. And then finally, we drew in the resultant by connecting those two together. Okay, so let's look at another example. So if we wanted to express one vector as the difference of the other two, we have to think about the addition. Think a little bit algebraically here. So let's think about the addition of vectors. So think about what we did in the previous lesson. When we were adding vectors together, we were adding, right, if we were to follow this, it would be one vector, so if I was looking at AB, one vector from the tail to the head, and then the next vector that we were adding to it went from the tail to the head, right? So it was tail to head, and then we'll say tail to head, okay? That's how we added them together, was by putting the tail of one to the head of the other. So I'll highlight that one in red so we can see. So if we think about the addition of this, then that would be like saying vector AB plus BC, okay? And then from there, our resultant goes from the start of our first vector to the head or the end of our second vector. So that would be our resultant, which is AC. So if we wanted to think about that in terms of subtraction, we just have to do what we know how to do algebraically. So we could say that AC and then minus either of those vectors over to the other side. Minus, let's say, BC is going to equal AB. Or we could have subtracted the other vector over to the other side. So we could have subtracted AB over to the side. Or we could say AC minus AB is equal to BC. Either of those would be reflective of rearranging the equation in terms of subtraction. Okay, so let's look at another example with vectors on bearings to see how this comes into play. So it says calculate the magnitude and direction of force F1 given the following information. So first of all, it gives us force 2, and then the resultant, which is force 1 plus force 2. So you have to be thinking about, they've given us F2, and they've given us the sum of F1 plus F2. So we have to do some subtraction to figure out what is F1 going to be. So let's sketch what they've provided to us. So they first started with saying they had a force of 20 newtons on a bearing of 65 degrees. So if I was to draw, let's draw this one first. So if I was to draw F2, it's on a bearing of 65 degrees. So remember, a bearing, a true bearing, and I know it's a true bearing because it has 3 digits, always starts from the north part of our compass. So if we were to draw 65 degrees, go something like this. This would be 65 degrees in there. Okay, and this is our force 2, which was 20 newtons. Perfect. So given the following, force 2 is 20 newtons. It says that our resultant, F1 plus F2, so we don't know what happens once it goes up here. It does something up here, and then at some point it's going to have to turn a corner in order for it to be a triangle. Right? We don't know what. This is going to have to be F1. We don't really know what's going on for F1. We'll just put F1 for now. And let's make sure, again, we identify that force 2 is moving this direction, so in a northeast direction. And then it'll have to turn some corner at some point and add to it force 1. And then finally, the resultant will go from the end of 1 to the tip of the other one. So this would be our F1 plus F2 force, which is 40 N. Okay, and that's on a bearing of 89 degrees. So from here to here, that's 89 degrees. Okay, so if we know that's 89 degrees, we can kind of work to figure out some more information. So we know that we have a side and we have another side. We're trying to figure out this third side. We have to look at what information we have in terms of what trig equations we can use. If we know that one bearing is 65 and one bearing is 89, well, we can find this angle inside our triangle by just subtracting those two. So we could say 89 minus 65 is going to equal 24 degrees. So that's the angle within that triangle. So now I can look at that and see, all right, well, I have a side, and then I have an angle, and then I have another side. So if I have side, angle, side, we're going to use cosine law. So hopefully we remember the pattern for cosine law. So we're working to find vector F1. So we square whatever that value is, and we're going to set that equal to the square of the other two sides. So 20 squared plus 40 squared minus 2 times those sides times the cosine of the angle opposite the side we're trying to find. So the angle opposite force 1 is 24 degrees. So if we simplify everything on the right, we should get 538.327268. Remember, we don't want to round yet. So if we take the square root, so that we can isolate for force 1, we should get 23.2 newtons. Okay, so this represents our magnitude. Okay, it says calculate the magnitude and the direction though. So we found the magnitude. Now we need to work on the direction. So the direction of our resultant is how we go from one force to the other force. So keep in mind that if we were looking at this in terms of force 1 and force 2, then our theta would be located here. So that's the angle we're trying to find. So we know now that this side over here is 23.2. So I have a side angle pair there with force 1, so I should be able to use sine law for the direction. So we're going to set up sine law in order to find our direction. So I know that the sine of theta divided by the side across from it, which is 20. And that's going to be equal to another side angle pair. So we'll take the sine of 24 degrees over 23.2. Okay, I'm going to cross multiply that 20 over to the other side. So I'll have 20 times the sine of 24 all over 23.2. And then finally we'll take the sine inverse of both sides so that we can isolate theta. So we'll have the sine inverse of 20 times the sine of 24 all over 23.2. So you should get that theta is equal to 20.5 degrees. Okay, so that gave us one angle within our triangle, right? But we need to know the direction of F1. So we have to try to think about where's F1. We know that F1 was somewhere up here. Right, that's where F2 turned and went on F1. So we have to think about how we can find this piece right here, right? Because that's the direction that F2 took in terms of a quadrant bearing. So we're going to figure out what that is. So we can figure out this angle here by recognizing that we have an opposite angle here. 65 degrees creates an opposite angle with this angle. So this is 65 degrees. We need to figure out this piece here. So we've already determined two of the angles. We know two of the angles are 24 degrees, and we just found the other one was 20.5 degrees. So let's figure out what the third angle. So therefore, the third angle is going to be equal to 180 minus 24 minus 20.5. So that third angle is going to equal 135.5 degrees. Well, we already know part of that third angle is 65 degrees. So to get just this little sliver here that represents the bearing that F1 is on, we're going to do 135.5 minus that 65. And that equals 70.5. So we have to think about that this is 70.5 degrees. Okay, we have to think about, in terms of a bearing, what does that really represent? Well, we have our south and our east directions here. So that bearing is on a southeastward direction. So south 70.5 degrees east. So if I wanted to conclude, I just figured out our direction. We already determined our magnitude. So we can say, therefore, the magnitude of F1 is 23.2 newtons, and it's on a quadrant bearing of south 70 degrees east. And that is it for your notes for today.